So right now you have come to the animation part, and hope you all like it. So from the animation part, we all came to know that 4-stroke diesel cycle consists of 4 processes, that is suction, compression, expansion and exhaust. So these 4 processes comprises the 4-stroke in the diesel cycle. Now I will discuss with you about the PV and TS diagram.
Though you have gone through the basics of my previous video, I am just recapitulating once the basics of diesel cycle. It is used in the CI engine, that means the compression ignition engine. It is first proposed by Rudolf Diesel in 1890s. In this case, only air is compressed during the compression stroke. This is a difference of diesel cycle and Otto cycle. As we know, in Otto cycle, air and fuel mixture is compressed in the compression stroke, but in diesel cycle only air is compressed during the compression stroke. Temperature of air after compression must be high enough so that the fuel spread into hot air burns spontaneously. In diesel cycle, it has much higher compression ratio than Otto cycle. It's typically between 16 to 24, and in case of diesel cycle, instead of spark plug and carburetor, it has fuel injector. So in the next slide I will discuss with you the various processes constituted in diesel cycle. So from the animation part of view, we came to know that the diesel cycle is composed of various processes. The first process is constant pressure suction process, in which air is intake in the engine cylinder, and then the adiabatic compression process, then constant pressure heat addition process. This is also a difference of diesel cycle and Otto cycle. In Otto cycle, we know that the heat addition process takes place at constant volume, then adiabatic expansion process, and last constant volume heat rejection process. So with the process, we know the processes now, and now we will go with the analysis of PV and TS diagram. So the suction stroke, that's the first. In this case, we know that the intake valve opens and the air comes into the engine cylinder, and the cylinder head moves from top dead center to bottom dead center. You can see here the arrows. You can see here the arrows. Here you can see the piston head is moving from top dead center to bottom dead center. So if we plot this in PV diagram, we will see that here it is the TDC, that means top dead center, and here it is BDC. In x-axis we have plotted the volume, and y-axis we have plotted the pressure. So in intake or in the suction stroke, as the piston cylinder moves from top dead center to bottom dead center, which means the volume is increasing. That's why look, 0 to 1 the volume is increasing, and as we considered that in ideal case the pressure remains constant during the suction stroke. So pressure at 0 P0 and pressure at point 1 P1 is same, P0 equals to P1. Next is the compression stroke. In compression stroke, the piston head moves from bottom dead center to top dead center, and both the valve remains closed. So look, as the piston moves from bottom dead center to top dead center, the air gets compressed. This is we termed as adiabatic compression, or This can be termed as also isentropic compression, and it is followed by PV to the power gamma equals to constant. This compression process you can see here in the PV gram, as with the compression the pressure increases and the volume decreases as the piston head moves from bottom dead center to top dead center, and this is the work input to the cycle during the compression stroke. And in case of TS diagram, we can say that as this is a adiabatic compression, which means it is an isentropic compression, the entropy of point 1 and point 2 remains same, but due to the compression process the temperature rises from T1 to T2. Then the ignition process start. Ignition process here is constant pressure heat addition process, and we are defining in PV diagram from 2 to 3. You just remember that this ignition is not a stroke, because the piston head remains at top dead center during the heat addition process, but during the heat addition process the pressure remains constant. That's why P2, that means pressure at point 2, equals to P3, the pressure at point 3. But as the heat addition is taking place, the volume is increased from point 2 to point 3. So if we look at the TS diagram, we can see as the heat addition process is taking place, the temperature is increasing from T2 to T3, and as well as the entropy at S2, that means at state point 2, the entropy is increasing from S2 to S3. Then the expansion stroke or power stroke. After ignition, the piston head moves from top dead center to bottom dead center, and the power stroke takes place. This is also a adiabatic expansion process or isentropic expansion process. It also follows the PV to the power gamma equals to constant relation. So we can see that from point 3 to point 4 the expansion process has taken place, and as expansion process has taken place, the volume from point 3 has increased to volume at point 4, that is V3 change into V4, and the pressure due to the expansion process, the pressure drops from P3 to P4. Here it will be P4. And in TS diagram we can see that as expansion has taken place, so the temperature will decrease from T3 to T4, and as it is an adiabatic expansion process, that means the entropy of point 3 and point 4 will remain same. So this is an isentropic constant process or constant entropy process. And in the last, there is the exhaust stroke. In exhaust stroke, the piston head will move from bottom dead center to top dead center and opening the exhaust valve. So in case of PV diagram, we can see that from 4 to 1 the exhaust stroke, or it can be said that constant volume heat rejection process is taking place here. So this is the constant volume heat rejection process, that way V1 equals to V4, and as the heat rejection has been taken place, so the temperature has been decreased from T4 to T1. In case of TS diagram, you can see the temperature has been decreased from T4 to T1. Okay, so as the temperature is decreasing, the heat reaction has been taken place, so entropy has been decreased from S4 to S1, thus constituting the whole cycle. I hope you have understood the PV and TS diagram. In the next video, I will discuss with you about the efficiency, about the thermal efficiency of the diesel cycle. Thank you.